How are you all? All good? Do we have any questions from yesterday's session? No questions? Okay, today we're basically going to start off with the mole concept. Moles basically is whenever any chemical substance, it has to be its amount or its quantity has to be measured. It is measured in chemical amounts which are measured in. They're basically measured in terms of moles. And the symbol which we use here is, let me know if the PPT is visible to everyone.
Yes, yes.
Okay. So it is measured in moles, and the symbol for moles is MOL, okay, which is basically the SI unit of the amount of substance. For instance, if I say that you have 1 mole of any particular atom, okay, or an element, or 1 moles of magnesium atoms, this would have a particular number or quantity of particles, right? And that number of particles is equivalent to the Avogadro's constant, which is 6.02 into 10 to the power of 23. Similarly, if I say 1 mole of oxygen molecules, how many molecules are present, how many particles are present within 1 mole of oxygen molecules, you would say 6.02 into 10 to the power of 23 moles. Molecules, okay, of oxygen molecules are present in a mole of oxygen. Okay, so this is basically 1 mole of any substance. It contains the same number of the stated particles, and that stated particles can either be your atoms, your molecules, or your ions. For instance, that if I ask you 1 mole of sodium chloride has how many sodium ions? Can someone tell me how many sodium ions are present in 1 mole of sodium chloride?
Let's relate to 6.02 times 10 to the power 3 divided by 2.
No, why divided by 2?
Because sodium chloride is a complete compound and you're taking sodium only.
No. The ratio of sodium to chloride ions is, in this particular compound, is 1 to 1, right? As a whole, if you see how many formula units are there, it is 6.02 into 10 to the power of 23. How many sodium ions or chloride ions are present? It would be again the same quantities. Why? Because the ratio of both of these ions, sodium and chloride ions, is completely the same. Are you getting me? But supposingly, if I say you have Fe, or let's take a aluminum oxide, okay, Al2O. The ratio here has changed to 2:3. Okay. So how many aluminum atoms, aluminum ions are present here in this aluminum oxide molecule, in this compound? It will become 2 times into 6 to the power of 10, 6 into 10 to the power of 23. Are you getting my point? Yes. Is this point clear so far? Okay. Then the mass of the same mole of any substance, the mass of 1 mole of a particular substance is known as the molar mass. This molar mass is basically the representation. For instance, if it is an element, then it will be the representation of or equivalent to the relative atomic mass, which will be given in grams. For instance, sodium atoms. They are completely, we're talking about elements which has not yet combined with any other element. So what is its relative atomic mass? Its relative atomic mass is 23 grams. Okay. We're going to add grams to this. This will be the molar mass of 1 mole of sodium atoms. Okay. This will be equivalent to the relative atomic mass. So for any element, the molar mass is the same as the relative atomic mass, which is given in or written in grams. For any compound, then what are you going to do? For any compound, for instance, you have sodium chloride or magnesium oxide or carbon dioxide. You will find out the relative molecular mass or the formula mass. And for instance, here it is going to be 23 plus 35.5. Whatever the answer comes up will be your answer here will be your relative formula mass in grams. This is going to be the molar mass of this particular substance, 1 mole of sodium chloride. Is this point clear?
Yes.
Okay, moving on. The Avogadro's law basically states that at the same temperature or and pressure, or at basically the room temperature and pressure, equal amounts of gases and equal amounts of gases, they basically occupy similar volume of space. For instance, if I say you have hydrogen, oxygen, 1 mole. 1 mole of hydrogen, 1 mole of oxygen, or 1 mole of carbon dioxide. Have all gases having same equal number of moles will also occupy same volume of space, and that volume of space is going to become 24 according to the standards. It is basically 24 decimeter cube, which becomes the molar gas volume at room temperature and pressure. What is room temperature and pressure? It is approximately 20 to 25 degrees Celsius temperature and 1 atmosphere pressure. Okay, so 24 decimeter cube, or in centimeter cube, it will become 24,000 centimeter cube. Okay, occupying all same quantities, all same number of moles of any particular gas. Okay, will have or will occupy same volume, and that will be referred to as its molar gas volume. So the molar gas volume means that the volume which is occupied by 1 mole of any gas. Okay, at room temperature and pressure, it would be 24 decimeter cube or 24,000 centimeter cube. Clear? Yes, are we clear?
Miss, 24 decimeter cube is equal to how much centimeter cube?
24,000
Okay.
multiplied by 1,000. Okay. And similarly, if you have to go from a smaller unit to a bigger unit, you divide it by 1,000. So from centimeter cube into decimeter cube, just divide it by 1,000. So for instance, if you have, so the relationship of amount of moles, volume, and the standard molar gas volume is amount of moles is equals to, or N is equals to volume divided by 24, volume in decimeter cube divided by 24. And if supposingly you have the volume in centimeter cube, then volume in centimeter cube divided by 24,000. You will rearrange this. For instance, if you want to find out the volume, then this 24,000 will be multiplied by n, that is the number of moles, or this 24 will be multiplied by n to find out your subsequent volume of any gas. Okay. For instance, if I ask you, how much is the amount of the volume of gas, volume which is occupied by ammonia, and the number of moles is 0.02. 0.02 moles of ammonia will occupy how much of volume in decimeter cube?
It will be 0.02 times 24, right?
Yeah, 0.02 times 24. The amount of moles will be multiplied by the standard molar gas volume. Okay, let's do another one. Whatever the answer comes up is going to be your answer in decimeter cube. For instance, if you have oxygen and it is the volume of oxygen which is given to you is 1200 centimeter cube. 1200 centimeter cube of oxygen will be how much amount of moles?
1,200 divided by 24.
Divide by 24 or 24,000?
No, divide by 1,000 first and then divide by 24.
No, 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 no. Why are you doing it separately? This is 20, this is 1200 centimeter cube. No? So volume in centimeter cube divided by 24,000. Okay, convert this molar gas volume in decimeters also into centimeter cube. Why? Because then only you will be able to cancel out both of these units, no? Right? If you do it separately, then your answer will be completely wrong. Okay. Whatever the volume is given to you, that is 1200 centimeter cube, will be divided by 24,000. Okay. Look at this. The volume will be divided by 24,000. Only the volume in centimeter cube will be divided by 24,000. Okay. To find out the number of moles. Whatever the answer comes up is going to be your answer in moles. Clear?
Okay.
Is everyone else clear so far?
Yes.
Okay, moving further. We've discussed this that a mole of an element, any element is equal to the relative atomic mass of that element in grams. And for instance, 1 mole of helium atoms will be the relative atomic mass of helium is 4. You're simply going to add grams to this to make it 4 grams, which will be the molar mass of helium atoms. 1 mole of lithium has a mass of 7 grams. The relative atomic mass of lithium is 7. Okay, and for 1 mole of any compound, it will be equivalent to its relative molecular mass or its formula mass. If it's in an ionic compound, it will be the relative formula mass. Otherwise, if it's a covalent compound, then it's going to be relative molecular mass in grams. Okay. And there is one more formula for to calculate the amount of moles in by using the relative molecular masses or the relative masses and the mass. Okay, that is moles is equals to mass upon mr or ar. Okay. For instance, if you have what would be the mass of 0.25 moles of zinc, you have to find out the mass. Mass is equals to moles times the, since zinc is the atom here, so you're going to use it in elemental form. It will be the relative atomic mass which you use. Okay. What the relative atomic mass of zinc is 65. 65 times 0.25 moles will become the mass of zinc, which is present in this much amount of moles. Are you clear?
Yes.
Okay, whenever you are writing any, you're showing your steps, you're showing your formula. Also, remember when you put your answers, do not forget to add in the units. For instance, here, the mass will be given in which units?
Gram.
Grams, yes, very good. Okay. All right, let me ask you one more. How many magnesium ions are present in MgCl2, 2 moles of MgCl2? Yes. How are you going to find this? How many magnesium ions are present? You have to find out the number of particles. Magnesium ions in 2 moles of magnesium chloride.
So Mg's mass is 24
Hmm.
multiplied by 2.
Mass multiplied by the number of moles. Okay. What formula are you using?
Mass is
Moles.
equal, yeah, number of moles equals to mass over molar mass.
Okay.
Molecular mass, sorry.
Hmm. What will you get then as a result?
48.
No, that is you have multiplied the moles by the molar mass. This
Yeah.
means you get the mass of magnesium. And I have asked how many magnesium ions are present. We have to calculate the number of particles.
So isn't that another formula to find the number of particles?
Yes, of course.
It's the number of particles equals to number of moles times Avogadro's constant.
Hmm.
So 6.02 times 10 power 23 times 2.
Times 2. Yes, very good. How many? What is the ratio of magnesium to chloride ions? It is 1:2, right? Right? Yes. This means there is one magnesium ion which is present in, and you have to find out its total amount of ions which are present in 2 moles. Okay. So the amount of moles multiplied by the magnesium ions ratio to the Avogadro's constant. Okay. Which is 6.02 into 10 to the power of 23. For instance, if I have to find out whatever the answer comes up is going to be your final answer for the amount of particles which are present in, or magnesium ions which are present in 2 moles of magnesium. Okay. Supposingly, if I was asked like how many magnesium ions are present in 1 mole of magnesium chloride, then what I would have said, I would have simply said that it is going to be 6 into 10 to the power of 23, right? But supposingly there are chloride ions that I have to take out. Then in 1 moles, how many chloride ions are present? The ratio is 2. This means there are 2 chloride ions which are present in 1 mole. This will become 1 times 6 into 10 to the power of 23, which makes it 6 into 10 to the power of 23 chloride ions. Clear?
Yes.
Okay, yes. And what about the rest of the class? Hamdan, Ibrahim, Ahmed.
Clear.
Okay. Write your answers in the chat box for this one. You have to tell how many molecules, water molecules are present in 15.7 grams of water. Its relative molecular mass is MR is 18. You have to find out the molecules.
We have to find the number of particles.
Yeah, the number of molecules, water molecules present in 15.7 grams.
Okay.
Yes, what is your answer? Mm, 5.25 into 10 to the power of 23. What did you guys do? You simply are going to take the mass. You will first find out the number of moles, right? Because to find out the number of molecules, we need to have the number of moles. Number of moles is we have to basically interlink uh, different formula. So mass is given to us divided by the molar mass, which is also written, or you can either find it out if it is not given to you. 15.7 will be divided by 18 to find out the number of moles. This number of moles will be then multiplied by the Avogadro's constant, which is 6.02 into 10 to the power of 23 to find out the total amount of particles which are present or total amount of water molecules which are present in 15.7 grams of water. Okay. But supposingly, if I say how many atoms are present in the same quantity, in 15.7 grams of water, how many atoms are present? Can someone tell me? What will you do then? Yes, Ahmed. How are you going to find out the amount of atoms in 15.7 grams of water?
You're going to find out the density,
The
density or concentration.
density or concentration. Why?
To find out the
We're
moles.
finding out the number of particles.
Oh,
Yeah, find
then
out the moles. How do we find out the moles?
by dividing the mass over the MR.
Hmm. So you got the moles. And then
Then what do we have to find?
we basically have to find how many atoms are there in total in 15.7 grams of water.
I don't know that.
How many atoms do we have here in total? In water molecule, in one water molecule, how many atoms do you have? A total of
6.02 times
no. How many atoms do you see here in one water molecule?
3.
Three atoms, okay? So this means this number three will be multiplied by, there are three atoms, which will be multiplied by your, what did you find in the last part? The amount of molecules, right?
Yes.
You can either use the same to find out the moles first, then multiply it by the Avogadro's constant, or you can simply say take that last answer to the last part to find out the total amount of atoms. Okay. So supposing that this is the answer to the last part, whatever the answer comes out. What is it? Mass is 15.7. 15.7 divided by 18 times 6 into 10 to the power of 23. What does our answer is? What is the answer to the last one? It is 5.25 into 10 to the power of 23. So you will multiply that answer. This is the total number of molecules which are present. If you multiply it by 3, you will get the total amount of atoms which are present in this particular mass of water which is given to you. Clear? Is this point clear so far? Yes. Let me know if you guys are all clear regarding this. Any complications? Okay, let's move on to the next one then. Next, we need to know how to find out. Wait a minute. Okay. For instance, if you have been given a stoichiometric equation, okay, and you have been asked, for instance, that magnesium reacts with oxygen to produce its own oxide, that is magnesium oxide. Is this equation balanced?
No,
No. What do we do?
you put 2 before MgO and Mg.
Yes. And after we get a chemically balanced equation, then only we start off with finding out moles, right? Or doing the molar calculations. So for instance, if you have been asked that how much maximum mass of magnesium oxide will be produced if 6 grams of magnesium undergoes combustion with excess of oxygen. You have to find out the mass of magnesium oxide which is produced as a result. How much mass of magnesium oxide will be produced if 6 grams is completely undergoes combustion? What are you going to do here? Either there are two ways, okay? Either find out the number of moles of magnesium and use it to find out the number of moles of magnesium oxide then, and then convert the number of moles into mass of magnesium oxide, right? By using the formulas that you have looked into, okay? For instance, one formula that you can use here is moles is equals to mass upon mr. Mr is usually not given to you. If it is given, well and good. If it is not, then you have to use the periodic table and then find it on your own. Okay. How much moles is present in 6 grams of magnesium? Mass upon mr. So 6 divided by, here, this is going to be magnesium, the molar mass will be 24. It will be the relative atomic mass of magnesium. So 6 upon 24 is going to be how much amount of moles? Yes, how much moles is it?
0.25.
0.25. So you're going to mention 0.25. According to your next step will be, this is the first step, okay, to find out the reactant moles, okay. The next step is after, and you always have to look into whether the equation is chemically balanced or not. Never start off with an imbalanced equation, okay. Then find out the molar ratio. Molar ratio between what? Molar ratio will have to be between magnesium and the one which you have to find out, that is magnesium oxide. According to the stoichiometric equation, if you look into, the coefficients are 2:2. Okay, this means that 2 moles of magnesium, they react with excess of oxygen to produce exactly 2 moles of magnesium oxide. Okay, according to this, you can either say that 2 moles produces 2 moles, or you can also say 1 moles produces 1 moles. This would mean that 0.25 moles of magnesium will produce exactly the same amount of moles of magnesium oxide as well, right? Yes. From this, you can find out the mass of magnesium oxide. What will be the mass of magnesium oxide? Moles times MR. What is the MR of magnesium oxide? 0.25 times
40.
40. Okay. So 0.25 multiplied by 40, and what will be the final answer? You're going to sum up their relative atomic masses, 24 plus 16, whatever the answer comes up is going to be your relative molecular mass, which is 40 here in this case scenario. Then what is the final answer?
10.
10. So 10 grams will be your final answer, or 10 grams of magnesium oxide is basically produced from 6 grams of magnesium. Okay. There is one other method you can use. Which method? Simply using the method of reactant masses. What is it? What is that? When you have the mass, okay, which is given to you, don't need to find out the number of moles. Use the molar mass, or the molar mass of this particular compound, this substance, magnesium, 24 grams, would produce how much molar mass of magnesium oxide? That is going to be 40 grams. Okay. And how much mass of magnesium oxide will be produced if 6 grams completely burn? Then you are going to cross multiply this. This means 40 multiplied by 6 divided by 24 will give you the final answer again, which is going to be 10 grams. Is this point clear so far? Yes, is this one clear? Yes, do we have any questions? Yes, Ayla, Basit, Ahmed, Ibrahim, Hamdan, Zoya,
Yes, it's clear.
all good? Okay. Moving on to the next one. Let's suppose that whenever a reaction takes place, there are reactants which are reacting with each other and then forming a product. For instance, if I say reactants A and B, they collide with each other, they have a successful collision, and as a result, they produce a new product. Okay. There must be one, or there might be one reactant there which is in excess, and the other reactant which is the limiting reactant. What does this means? The limiting reactant is the one which is basically um, in limited quantity. The excess reactant is the one which is present in excess amount, right? As a result of which the product which is formed would be of a certain quantity, right? The limiting reactant will be used up first. Whenever the limiting reactant is used up first, what is going to happen? Because the excess reactant is already in excess quantity, right? So excess reactant here, supposedly a reactant A, will be left behind. B will be completely used up as it is the limiting reactant. Whenever all this limiting reactant will be used up, what do you think? The reaction is going to continue, or the reaction is going to stop at that point in time?
Reaction will stop.
Yes, the reaction is going to stop. This means that the quantity of the limiting reagent, that is B, will definitely impact the quantity of the product which is produced. Okay. For instance, if I say this is 20 grams and this is 5 grams, this produces supposedly 10 grams of C. Okay. But in the next one, this stays in excess quantity. I have increased the quantity of the limiting reagent. Do you think that this limiting reagent will have will increase the amount of product C, or is it going to decrease the amount of product C, or is it going to stay the same?
Increase the amount of C.
Yes, it is going to increase the amount of C, okay, which is being produced. Since whenever the limiting reagent is changed, the quantity of the limiting reagent is changed, it is always going to impact the amount of product which is formed. All right. However, if it does not, and also it affects the progress of the reaction as well. Okay. Is this point clear so far?
Yes.
Okay, for instance, if you have sodium, which it reacts with sulfur, how do we find out which one is, what will be formed if sodium reacts with sulfur? A sulfide is formed, sodium sulfide. Can someone tell me its chemical formula? Yes, what is the chemical formula of sodium sulfide? Anybody? Na2S. Sulfur A, sulfide ion is S2 minus. Okay. Any non-metal ions, whenever they form anions, their name ends in IDE. Okay. For instance, sulfide, oxide, chloride, iodide, fluoride. Okay. Here, then you have to have a balanced chemical equation. Supposingly, I say that 9.2 grams of sodium reacts with 8 grams of sulfur, okay, to produce sodium sulfide, okay. Now you have to tell here which reactant is the excess reaction, which one's the limiting reaction. How are you going to know? We are going to first find out the number of moles of both of these reactants. How do we find out the number of moles of sodium and sulfur here? I think moles is not a good topic. You guys don't like it. Seems so. Is it? Yes, Ayla. Do we have Ayla around? Okay, no response from Ayla. Anybody else? Tell me the number of moles of sodium here. 9.2 mass upon MR, or the molar mass. Okay, 9.2 will be divided by the relative atomic mass of sodium. What is the relative atomic mass of sodium? 23. You simply have to look into your periodic tables for this one. Mass of sulfur, 8 divided by 32 mole atomic mass of sulfur here. Okay. What are the final answers? The number of moles of sodium is going to be? Yes, grab your calculators.
0.4,
0.4. And the next one?
0.25.
0.25. Okay. So 0.4 and 0.25 moles. According to the stoichiometric equation, what is the molar ratio of both of these reactants?
2:1.
Yes, 2:1. Very good. So when you see that this is 2:1, this means that 2 moles of sodium will react with 1 mole of sulfur to produce this sulfide. Okay. So if 0.4 moles of sodium is used, it should produce how much moles of sulfur then? Half the quantity, obviously. 0.4 divided by 2 is 0.2, not 0.25. This means sulfur is in excess and sodium is the one which is the limiting reagent. Are you getting my point? Is this point clear so far? Do you want me to explain it furthermore?
Yes.
If you look here, whenever a question comes up where they ask you which one is the limiting reagent and which one is the excess reagent, the first step is to use the amount of mass. If the mass is given, just use it to find out their respective number of moles. Okay. When you get the number of moles of both of them, then you're going to take out the molar ratio from the chemically balanced stoichiometric equation. Okay. Here it says 2 moles of sodium reacts with 1 mole of sulfur to produce its sulfide, right? So if 0.4 moles of sodium, they are reacting with 0. How much of the quantity should be of sulfurs? It should be half of it, right? According to this molar ratio. So half of 0.4 should have been 0.2. But here we have greater quantity of sulfur. This means sulfur is the excess reagent. Sulfur is the excess reagent and sodium is the limiting reagent so far. Got it? Is this one clear? Yes, any questions, any queries? All right. I will end the session till here for now. Tomorrow we don't have a class. So next week we will begin with this. And in this week's quiz, you will have the relative formula mass and empirical formula, writing equations, and everything earlier than this topic. Okay. Maybe I give you some questions related to limiting reactant and excess reactants. Okay. And the quiz will be on Google Classroom. All right. Take care. Allah Hafiz. Thank you. Bye-bye.
Love is.
Allah Hafiz. Allah Hafiz.